Hello and welcome to Uncle Matt's Online Academy. This is the second lesson we are going to have on specific heat capacity. And in the previous class, we talked about how to calculate specific heat capacity using the formula Q is equal to MC theta. Q is equal to MC theta. Now, there's one special thing about this formula. This Q is very important. Q is heat energy, and we know that energy is interconvertible, which means that we can convert energy from one form to another form. We can convert heat energy to electrical energy, and we can convert electrical energy to mechanical energy, and from mechanical energy to chemical energy, can convert it to any form of energy that we can think of. Now, what this actually means is this: energy is interconvertible and conserved in a perfect system. Conserved means that it does not depreciate or reduce when it moves from one form to another form. Energy does not reduce in form or increase when it moves from one form to another, which means that if we're moving or converting electrical energy to mechanical energy, if the system is perfect, if there is no way that the energy will get lost to the environment, it will still be the same thing. The same value for electrical energy will be the same value for the mechanical energy after the conversion. If you are converting from electrical energy to heat energy, the value you get for the mechanical energy will still be the same value you get for it when it has been converted to heat energy. Now, the implication here is this: that when we have the energy as an electrical energy, we equate it to heat energy and use it to replace Q in this formula. For instance, if we are given the formula or values that we can use to calculate electrical energy of an object, what we do is that we get the electrical energy and assume that that electrical energy will be converted to heat energy. Then we use it as our Q. If we are not given Q, but we are given values that can help us to calculate mechanical energy of an object, we get the mechanical energy and equate it to Q, to heat energy, because energy is interconvertible. When we equate it, then we put this other formula there and then use it to calculate for what we are looking for. For instance, for potential energy. For potential energy is mgh, where m is mass of the object, g is acceleration due to free fall, and h is height of the object, height from where the object is. Now, if we have these parameters and we are looking for the specific heat capacity of an object, we can calculate it by equating this to the formula of specific heat capacity, which is MC theta. We equate the potential energy to this formula. Now, if we equate this thing, what we do is that since it is the same object that we are converting its potential energy to heat energy, and from the heat energy we are looking for its specific heat capacity, what we do is that we just cancel this and this. The mass here is the same mass here because it is the same object. So if we have cancelled the mass, it becomes that GH is equal to C theta. GH is equal to C theta. Now this means that if we have an object that is placed at a certain height, we can get a specific heat capacity if temperature is given to us, or we can get the temperature if the specific heat capacity is given to us by equating the GH. G is acceleration due to gravity, which is always 10. So if we know the height, we just put the acceleration value, which is 10, multiply by the height, and equates to this, and we get whatever we want. Now that is a case of one of the examples that we have here. In this example, we have what we have in this example is example 1. A body of specific heat capacity, 450 joule per kilogram per Kelvin, falls to the ground from rest through a vertical height of 20 meter. Now assuming conservation of energy, calculates the change in temperature, of the body on striking the ground. Now we are given that G is equal to 10 meter per second squared. What we do here, solution. Now let's bring out the parameters given to us. We have that a body of specific heat capacity, we know C as 450, falls to the ground from rest through a vertical height of 20 meter, we know H as 20 meter. Now assuming conservation of energy, calculates the change in temperature of the body on striking the ground. G is equal to 10 meter per second. So we know our C as 450. Then we know our H as 20. Then we know G as 10. So we are looking for change in temperature is represented with theta. So we are going to calculate theta. Now how do we calculate this? Now this, since we have H and we have G, this is a case of converting an object from potential energy to heat energy. A body of this falls to the ground from rest. From rest means that it has been in potential energy. So the formula for potential energy is mgh. Now this is equal to Q. Since this is equal to Q, and we know that Q is equal to mc theta, now we equate this to this. Now which means that now mgh is equal to mc theta. We are talking about the same object, which means that the mass here is the same mass here. So we cancel this mass, and now we are going to have that gh is equal to c theta. Gh is equal to c theta. Now we know our g as 10 and we know our h as 20. This is equal to c is 450, and we are looking for our theta. This means that theta now is equal to 10 times 20 now over 450. If this is coming to this side, 450 over 450. Now this will give us that theta is equal to 0.444 something Kelvin. So this is the answer. So this is a way to convert potential energy to heat energy, and now use the calculated value for the potential energy to solve for the temperature or the specific heat capacity, whichever one we are looking for.